In today's video, I would like to introduce you a very nice problem. It's coming from Bulgarian Mathematic Olympiad edition 2004. Here is the following setup. We have 2 to the a plus a is multiplied by b squared minus 3 to the c equals 283. Okay. In fact, this is very nice and interesting problem. It carries a nice tricks. So before we move on to the solution, I would like to remind you, do not forget to support our channel, like, comments, subscribe. So let's get into this one. Okay. So the first thing that I'm going to think of this problem. So since you have a power of 2 here, so let's get some values of a in order to reduce this equation to the sum module. Okay. So let's assume if a is super equal to 3, then reduce the equation to the mod 8. Okay. This is the first step. By the way of contradiction, suppose a is super equal to 3. Now I will be able to reduce this equation to the mod 8 because this one will be 0, because I get 8 here as a minimum value here. This one also is 0. This one I'm going to check what's the remainder of this one when you divide this one by 8. This one I'm going to go through the chart. Okay. So before we proceed with the solution, I'm going to go through the chart first. Now here is the following chart. So I'm going to take the possible values for this one to reduce this one to the mod 8. So for 0 I get 1 because 3 to the 0 which is 1. For number 1 I get 3. For number 2 I get 1 because 3 squared which is 9. 9 I will have 1 more than 8. 3 I get 27. 27 I get 3 more than 24. Number 1 3 1 3. This one is going all the way down like this. Okay. So which means you have only 1 and 3 as a reminder for the when you divide this one by mod 8. Okay. Now I'm going to leave this chart here because it's very important. I'm going to use it all the time. So now I'm going to check 283. So I get the following. I get 2 to the a. 280 is the same as 280 plus number 3. Okay. Now I'm going to reduce this one to the mod 8. If I'm going to reduce this one to mod 8, this one will be 0. This one will be 0. This one will be 0 because I have assumed a is super equal to 3. So what I'm going to left with, I will be left with minus 3 to the c, which is a congruent to 3 mod 8. Moving this minus sign over to the right of the congruence, then I will get 3 to the c is a congruent to minus 3. I'm going to add number 8. Okay. This one is a congruent 8 minus 3, which is 5. Is a congruent to 5 mod 8. So when we divide this one to the mod 8, I get a remainder 5. But the chart gives us only 1 and 3. Okay? Which is impossible. What does mean impossible? We have contradicted our assumption, which means A must be in this set. 0, 1, and 2 only. That's it. We're done with the values of A. We know that this A doesn't have any solution above this point. So which the solution, the only available solution which we can get, this one, 0 or 1 or 2. Okay, now let's get rid of this one and move on to the next step. Oh, now we are going through each case. When we have a equals 0, replacing a with 0 here, this one becomes 1 plus 8 is multiplied by b squared minus 3 to the c, which equals 283. I'm going to cancel number 1 from the left and the right. I will be left with 82 here. 282. Now if you take a look at the left hand side of this equation, this is odd, but this one even. It's impossible. It's a contradiction. Okay. So which means this case equals 0 doesn't work. Let's move on to the seventh case when we have a equals 1. I'm going to do the same thing, replacing the value of a into this one here. I get number 2 plus 8 is multiplied by b squared minus 3 to the c, which equals 283. Then subtracting number 2 from the left and the right, I will be left with here with 281 here. This one you will be cancelled out. Okay, now I'm going to do a little job here. We know this 281 is the same as 280 plus number 1. Let's do the same thing that I have done before, reducing the equation to the mod 8. This one, if I'm going to reduce it to mod 8, I get 1 mod 8, because this one is 0. Okay, for the left hand side of this equation, also this one is 0. I will be left with this one. I get minus 3 to the c is congruent to 1 mod 8. Okay, let's move over this minus to the right. I get minus number 1. Let's add number 8. I get minus 1 plus number 8, which is congruent to 7 mod 8. You see, let's go back to the chart. As we discussed before, we know this one 3 to the c, they have the remainder number 1 and 3 only when you divide this one to mod 8. Okay, when you reduce this one to mod 8. So but this one we get number 7. It's impossible also, which means this case doesn't work also. Okay, let's move on to the final case. That's the tricky case. Okay, we will have a lot of work there. That's the challenge case. Let's get rid of this one and move on to the next step. For this final step, when we get equals to, okay, I'm going to do the same thing, replacing this value into the original equation. I get 2 to the 2, which is 4. I get number 4 here, plus 8 is multiplied by b squared, minus 3 to the c, which equals 283. So I'm going to do the same thing, moving over this number 4 to the right, becomes minus 4. I get 280 minus 4, which is 279. Now let's do a little work here. I'm going to reduce the equation to the mod 8. But before we do that, I would like to say 279 is the same as 280 minus number 1. Okay? So by reducing the equation to the mod 8, so I get this one 0. I will be left with minus 3 to the c is congruent to minus 1 mod 8. So cancelling minus sign from left and right. Here is the thing. It shows we have a solution for this equation, because we got a remainder here, number 1. But when this one happened at even number. If you take a look at 0, we get a remainder number 1. If you take a look at number 2, get number 1. Number 4, get number 1, and so on and so forth. So which means this one is telling us c is an even. Okay? If c is an even, let's set c equals 2m. Now we know which direction we are going to. Okay? Just replacing the value of c with 2m and solve the equation. Okay? So I get 8 is multiplied by b squared minus 3 to the 2m, because I have replaced c with 2m, which equals 280 minus number 1, because 279 equals 280 minus number 1. Okay? So notice here, this 280 equals 25 is multiplied by 8. Okay? Now next thing up, I'm going to move over this 3 to the 2m to the right and bring back this term to the left and make number 8 as a common factor, since we have 8 is multiplied by 34. Since we have 8 is multiplied by 35, because you get number 8 here as well. Okay? At the same time, when you move over this term to the right, I will have a difference of 2 squares, then we will factor that. Okay? My equation, it will be expressed as b squared, 8 is multiplied by b squared, minus 35, which equals 3 to the m minus 1 factor 3 to the m plus number 1. Okay? Here is a challenge point. So we know that GCD of this one, GCD of these terms, this one and this one, is super equal to 2. Because we get this term is an even, this one is an even. Okay? It's more clear here, 8 is a known value, which means 8 can divide these two terms. Is okay. But this one we don't know about, we don't know any information about this one. Okay? Now I'm going to use a nice trick here. Now let's take this equation at the top and go ahead to the proof. Okay, now with the next thing up, I'm not going to work on this term because it is going to give us a lot of problems here. So I'm going to use a nice trick in order to solve this equation. So before we proceed to the solution, I'm going to go through the chart. I'm going to take the integer and square it and reduce it to mod 3. Let's do that by using the chart. So I will have the following chart. This one will be reduced to the mod 3. I went through the chart prior to getting to the solution because I will need it at the end. That's why I'm going to put it here. I'm going to prove it, and at the end I'm going to use it. Okay, so it's more simple here when you reduce this, when you take the integer and square it, reduce it to the mod 3. So for 0 it simply is 0, for 1 it simply is 1, for 2 is 4, you get number 1 more than 3, for 3 is 9, 9 is clearly is 0, 4 square 16, 16 was 1 more 15, for 25 is 1 more 24, you get the remainder number 1, for 6 square which is 36, you get 0, and so on and so forth. We get x squared belongs to 0 and 1 only. Okay, so now we are ready to move on to our proof. Okay, the best way that I'm going through, I'm going to work on m by the way of contradictions. Suppose m is super equal to 2. Okay, so I'm going to reduce above equation to the mod 9. Why is 9? Why is mod 9? Because I see here, because I want to work on this power of 3, because this one, if we have m is super equal to 3, I get 0 here. That's the purpose of to reduce this one to mod 9. Okay, let's convert this equation a little bit. Number 8 is the same as 9 minus number 1 factor b squared. It will be stayed the same. Minus 25 is 36 minus number 1, 3 to the m minus number 1 factor 3 to the m plus number 1, like this. Okay, then reducing the equation to the mod 9, this one will be 0, this one will be 0 because 36 equals 9 is multiplied by 4. This one is 0, this one is also 0 because I have m is super equal to 2. I got 9 here. So if you divide this 3 to the m by 9, you will have a 0 as long as you have m is super equal to 2. So I will be left with this one, minus 1 factor b squared, minus with this minus becomes plus, is a congruent with this minus 1 factor 1, which is congruent to minus 1 mod 9. Also, this minus 1 will be cancelled out with that one over the right, this one. I will be left with the following, b squared plus number 1 is a congruent to 1 mod 9. This one implies, so since we get number 1 here, I'm going to cancel number 1 from the left and the right. So I will be left with b squared is a congruent to 0 mod 9. B squared is a congruent to 0 mod 9. So since we get b squared here, we get 0, we get 9 here. I'm going to reduce this divisor. I'm going to take the square root for everything. So this one implies b is a congruent to 0 mod 3. According to the divisibility statement, we get 3 divides b, which means b is a multiple of 3. So which means b is going to be written on this form. 3 is multiplied by k. So the next thing up, I'm going to take this value of b and insert it back into the original equation. So I will have the following. This one will be replaced with number 2. I get 4. By moving over this number 4 to the right, I get 8 is multiplied by b squared minus 3 to the c, which equals 279. Then replacing this fact into this one, I get 8 factor 3k squared minus 3 to the c. So we know this one is giving us 9 is multiplied by 8 is multiplied by k squared. Because I have square is 3, becomes 9, multiply 8 by k squared, and minus 3 to the c, which equals 279. Okay? Notice here, 279 is the same as 31 is multiplied by 9. Okay? Since we get 9 everywhere, here and here, we know 31 is the same as 3 cubed, which is 27, plus number 4. Okay? So I'm going to move over this term to the right and bring back number 4 to the left. Okay? Then take number 4 as a common factor. I will have the following. I will have 4 factor 8 is multiplied by k squared minus number 1, which equals 3 cubed. I'm going to take it as a common factor as well. So by moving this term to the right, I will get 3 to the c minus 3, because I'm taking it as a common factor, plus number 1. Okay? I think it's more clear here. Now we are going to consider the condition of k. K must be super equal to number 1. Okay? Because if we replace k with number 0, I get b equals 0. If b equals 0, which means this one will be 0. And then while we have this one was 4, by moved over this number 4 to the right, becomes 279. So I get minus 3 to the c, which is 279. It's clearly impossible because we got minus sign here. On the other hand, this one becomes not power of 3, which is impossible to have k equals 0, which means k is super equal to 1. If k is super equal to 1, this one is a positive integer. Okay? Which means the right hand side of this equation is a positive integer as well. To make it more simple, just I'm going to take number 3 as a common factor. 3 factor 3 to the c, because 3 will go inside, will add it in this exponent, becomes 3 to the c, plus number 27. Okay? Now it's more clear. We have an integer because c is super equal to 1. Okay? We know c is super equal to 1 because we get c equals to m. Okay? When you explore this one, you find c cannot be 0. If c equals 0, which means m equals 0, which is impossible. Okay? So now, since this one is factorized on this form, so I'm going to, since we have 3 as a common factor here, I'm going to reduce the equation to the mod 3. This one is clearly is a congruent to 0 mod 3, which means the left hand side of this equation is a congruent to 0 mod 3 as well. But 3 cannot divide 4, which means 3 divides this one. Okay? Let's take this one here. So we know 3 cannot divide 4 based on the expression of this equation, which means it's immediately 3 must divide 8 k squared minus number 1, as we have here. Okay? So let's express one by using the modular arithmetic. So we get 8 is multiplied by k squared minus number 1 is a congruent to 0 mod 3. Equivalent, 8 is multiplied by k squared is a congruent to 1 mod 3. Let's multiply both sides of this equation by number 2. If I'm going to do that, I will have 4 k squared here. I get 4 k, all is raised to number 2, which equals, let's put this one as a capital X. Let's put this one on the form of the integer square, that x squared here, which is a congruent to 2 mod 3. So we have ended with this nice expression. You might say how I get to this one. It's more simple. I just multiplied number 2 by both sides. I get 16 k squared. 16 is the same as 4 k squared as I have here. So this one becomes 2 as I have here. This one, it's impossible. It's a contradiction. Why? Because if you go back to the previous chart that I have done before, you get the possible remainder when you reduce the integer square, you get only 0 and 1, not number 2, but we get number 2 here. It's a contradiction, which means what we have contradicted here, we will have contradicted our assumption, because we have assumed m is super equal to 2, which is impossible, which means m must take only 0 and 1. Okay? Now we'll have a solution for this equation by checking these two cases, 0 and 1. Okay? Let's get rid of this one and move on to the solution. We are going through each case. M equals 0. Let's replace m with 0 into this equation, I get 8 is multiplied by b squared minus 35, which equals this one 3 to the 0, which is 1, 1 minus 1, which is 0. Okay, it's clearly we have 0 here, which means b squared equals 35. It's clearly it's impossible because 35 is not a perfect square. Okay, let's move on to the final solution. M equals 1. I'm simply going to replace m with number 1 there. I get 8 is multiplied by, I get 3 to the 1, which is 3, 3 minus 1, which is 2. The other one I get 3 to the 1, which is 3, plus number 1, which is 4. The product is equals 8. I'm going to cancel out number 8 from the left and the right. I will be left with b squared minus 35, which equals number 1. Equivalent, b squared equals 36, because you get 35 plus number 1. This one is clearly is going to give us two solutions. Sorry, the problem it came over integer, not because I thought it was just non-negative integer. Okay, so which means we will have a negative integer as well here. Okay, but you will have the solution, negative solution, only on b, because since we have b squared here. But for a and c, we cannot have any negative solutions. Okay, so we are in the safe spot now. So let's take the following solutions. Since we get only m equals 1, is giving us c equals 2, because replacing number 1 into c is giving us c equals 2. So now I will have the following solution. I get a, it's clearly it was number 2, because we have discussed our case on this integer equals 2. It gives us equals minus 6 with c equals 2. I will have another solution, which is a equals 2 with b equals 6, because we have two possibilities here, with c equals 2. So I came up with these two solutions. That's what I have here. So I have ended this video. By the way, don't forget to hit the subscribe button and support the channel. And thank you for watching. I will see you next video. Bye.